Hack-Tech's Virtual Training Materials. Advanced Textiles Manufacturing Industry. Learning Unit 4. Standards and Characterization of Functional and Smart Textile. Lesson 2. Textile Properties of Smart Textiles and Their Characterization. In this lesson, you will learn about the most common tests used to determine the textile properties of smart textiles. The strength-related properties, which give a measure of the behavior of the material under tensile, tearing, and friction forces, determined with tensile, tearing, abrasion, and pilling tests, will be described. The haptic properties, related to the tailorability of the material, as well as with the wearing durability of the material, will be following described. Finally, the most common tests used to determine the comfort-related properties, such as the flexibility and wrinkle resistance, the air and water permeability, and the capacity of textiles to absorb water, are described. The mechanical behavior of the textiles when are subjected to axial tensile forces is measured through tensile tests. In the tensile test, a specimen with specific dimensions is stretched at constant speed until breaking. The necessary force to perform the stretching, and the elongation of the material, are registered. The maximum force, given in newtons, and maximum elongation, in percentage, are determined. There are two possible configurations for a tensile test, the strip method and the grab method. In the strip test method, the width of the specimen fits with the clamp's width. In this test, typically a specimen of 5 by 30 cm is used with a distance between clamps of 20 cm. In the grab test, a wide specimen is mounted centrally in the clamps. The specimen has dimensions of 10 by 15 cm and the distance between clamps depends on the fabric type. In both cases, 5 specimens per direction must be tested, whereas the clamping distance and speed will depend on the type of test and fabric. The tearing test determines the resistance that offers a fabric to continue tearing at a constant speed, once started. They are performed in the same dynamometer used for tensile tests. In this case, the average force for tearing is determined from the curves. There are two possible configurations for a tearing test: the single tear method, and the double tear method. The single method uses a trouser-shaped specimen. The double tear test uses a tongue-shaped test specimen. In both methods, 5 specimens have to be tested at a constant rate of 100 mm per minute. The most common method to determine the resistance to abrasion of textiles is the Martindale test. In this method, two circular surfaces are in contact. The upper surface is covered with the fabric to be tested, while the bottom one can be covered with the same fabric, or with an abrasive surface, such as a standard fabric for example. The specimen is subjected, under a specific load, to the scrubbing action with the abrasive element, following a translational movement that forms a Lissajous curve. At the same time, the specimen holder rotates freely around its own axis, perpendicular to the horizontal plane. The test consists of determining the number of cycles necessary to produce failure, reached when wear-off is observed in the fabric, or the loss of weight suffered by the test piece after a certain number of abrasion cycles. Pilling tests consist on submitting the specimens to mechanical friction, to evaluate their appearance afterwards by comparing them with a scale of photographic patterns. There are two types of methods to determine the resistance to pilling of the textiles: the container methods, and the flat methods. The container methods are the best to simulate the behavior of a fabric during use. These methods use different containers that are coated on their inner wall with moderately abrasive surfaces, usually cork. The specimens are introduced into the containers, where remain for a long period of time, rubbing against each other and with the walls, due to the rotation of the containers at low speed or at high speed. Pilling can be also measured with specimens placed in a flat position, in contact with another fabric or surface located in a parallel plane. This uses the Martindale principle, as on the abrasion test, but evaluating the formation of the little balls in this case. If you want to learn more about how to test strength-related properties, you can find extra information in the readings of this lesson. Tailorability consists on the evaluation of mechanical properties of fabrics, when subjected to small forces, in order to predict the resistance of the fabric to overcome industrial clothing operations. The tailorability is measured using the fabric assurance by simple testing equipment, also known as FAST. FAST consists of 3 instruments, to measure the compressibility, stiffness, and extensibility, and a test method to measure the shrinkage and hygroscopic expansion. The compressibility is measured as the difference of thickness of the fabric when it is subjected to 2 types of compressive loads of 2 or 100 grams per squared centimeter, respectively. The flexural stiffness is measured in both warp and weft directions by the method of cantilever length. And the extensibility is measured subjecting the fabric to different loads. The dimensional stability of the fabrics is measured determining the relaxation shrinkage or ER, and the hygroscopic expansion or EH. In this test, the specimen is firstly subjected to a oven drying and the distance between the marks of the specimen is determined. Then, the specimen is immersed in distilled water, dried in room conditions, and the distance between the marks is measured again. Finally, the specimen is oven-dried, and the distance between marks determined. From this information, the ER and the EH are calculated. The drapability is determined with the drape tester. In this test, a circular fabric is placed horizontally on the top of a metal disc smaller than the fabric. Just below the center of the circular specimen, a light bulb projects a beam of light that is reflected upwards under specific conditions. Then, the projected shadow is determined. In smart textiles for clothing and for home textile applications, it is very important to determine the resistance of the textile's performance after subjecting it to washing. Washing fastness test consists on subjecting the fabrics to several washing cycles, usually 1, 5, 10, 20 or 50. Color fastness is the measure of the retention of textiles' original color, when they are exposed to different actions or conditions under use, like light, washing, rubbing to different surfaces, wear, ironing, high temperatures, perspiration, water, or seawater, among others. For each smart textile, depending on the application, different color fastness have to be selected and tested under the corresponding standard. If you want to learn more about how to test haptic-related properties, you can find extra information in the readings of this lesson. Shirley method is the most used to determine the stiffness or the flexure resistance of textiles. The procedure is based on the principle of a cantilever, and consists of determining the length of fabric necessary for the cantilever end to form a fixed angle with respect to the horizontal plane. The most widespread method to study the wrinkling tendency of fabrics is the one that measures the ability to recover wrinkles after subjecting the fabrics to wrinkling under a specific load. When the load is removed, the recovery of the specimen is allowed and the remaining wrinkle angle is measured for samples horizontally folded or vertically folded. The water vapor resistance is the opposite of the water vapor permeability, which is the capacity to allow moisture to pass through the fabric. The different methods can be divided in gravimetric or hot plate methods. The most simple and used ones are the gravimetric. The thermal resistance of the fabric measures the capacity of the textile to create a thermal barrier between the heat source and what has to be protected by the fabric. It is very important to know the level of protection for clothing and technical applications. There are different tests to determine the thermal resistance of textiles, but the most common used is the hot plate test. The air permeability of the textiles is a very important property for those applications that need to control the amount of air that can pass through the fabric under certain conditions. The air permeability is understood to be the velocity of the airflow passing perpendicularly through the fabric, under the conditions of test surface, pressure drop, and time, specified by the standard. On the other hand, the water wicking capacity of the textile, meaning the capacity of water to pass through the fabric when driven by capillary forces, is an important property related to the comfort. This property is usually tested by wicking an end of the fabric specimen in water, and then determining the wicking distance at different time intervals in vertical wicking test, or by determining how the water spreads in a fabric in an horizontal wicking test. In this lecture you have revised how to determine the textile properties of smart textiles and the common standards used for testing, the strength-related textile properties through tensile, tearing, abrasion and pilling tests. The haptic-related properties, by means of tailorability, drapability and fastness evaluations. And the comfort-related properties, measuring the stiffness, recovering angle, water vapor resistance, air permeability, thermal resistance and water wicking.